Another concept that we need to discuss is the concept of ion substitution. Ion substitution occurs at the time the mineral is initially being formed. And when we talk about ion substitution, we're talking about the replacement of the central cation by a different cation other than what would normally be found there in a highest content or in the most appreciable quantity. In other words, we've already reviewed the fact that inside of a tetrahedron we would normally have a silicon, and inside of an octahedron we would normally have an aluminum cation. Well, when ion substitution occurs, the only cation that can substitute for silicon in a tetrahedron is the element aluminum. The only cations which can substitute for aluminum inside of an octahedron is either magnesium or, to a much lesser extent, but it can still do it, calcium. So calcium and magnesium can substitute for aluminum inside of an octahedron, and aluminum can substitute for silicon inside of a tetrahedron. Now, if we compare silicon to aluminum in the tetrahedron, silicon has a charge of +4, aluminum has a charge of +3. The reason that aluminum is the only thing that can substitute for silicon in the tetrahedron has to do with the number of positive charges and the physical size of that element, or in this case, ion. Aluminum is larger in physical size than is silicon, and it only has 3 positive charges on it. So if we have substitution occurring in the tetrahedrons, we're going to have aluminum with a lower positive charge and larger physical size replacing silicon. This is going to cause a weakening of the mineral structure. Larger physical size forces the oxygen ions further apart. Lower positive charge gives us less positive pulling force to help hold those oxygens together into that tetrahedral arrangement. If we have substitution for aluminum in the octahedron inside of this structure, then it's either going to be a magnesium or calcium. Well, magnesium and calcium both have 2 positive charges, and they are each larger in physical size than is the aluminum cation. So calcium and or magnesium will not have the same ability to hold these oxygens in the octahedron together as does aluminum, and they'll be larger in physical size, which will naturally push them further apart also. So whether we're talking about substitution in the tetrahedron or substitution in the octahedron, ion substitution, which is the replacement of the central cation at the time of the initial mineral formation, is a phenomenon which will cause that mineral structure to be weaker. That is to say that these minerals will be less resistant to weathering or more easily broken down. Now that can be both good and bad. It's good from the standpoint of soil development and from the standpoint of that soil yielding nutrients in an available form quicker to the plant. It can be detrimental in a high moisture, high temperature, humidity environment where soils are developing quite rapidly, because these minerals will be broken down and either taken up by plants and or leached from the soil, and consequently those soils will become non-fertile and or non-productive more quickly if the minerals in those have a high degree of substitution and a lower degree of resistance to weathering.